introduce Steve Fines. I currently work with CoreLogic as an analytical software engineer and software architect. My primary responsibility is coding in Java and as well as C++ and a few other languages. So today I'm going to talk about converting from being a full-time Java developer to working with a functional language, in this case Scala, which can be a very troubling transition for people who are really deep in the object-oriented and imperative development world. So as part of that, I'm going to talk about it kind of in three steps. First off, I'm going to talk about investigating the transition, and by that I mean making the decision, the things that go into making the decision to change languages. And the things you have to do when you go, hey, I'm going to invest some of my hard-earned private time to learn this language, which may or may not be popular, which may or may not have jobs in the future. The second part I'm going to talk about in a very short segment about the tools of the trade, which is what's really required to develop in Scala. And then kind of what are some good things and what are some bad things about the Scala development environment and some of its ancillary tools, which can make it a little bit rough for somebody who's used to a very mature software ecosystem such as we have in the Java enterprise space now. And then I'm going to talk about the differences in approach. This is going to be probably the longest part of the discussion. I'm not going to hit everything. One thing I'm not going to do is cover the syntax for developing in Scala. The language syntax is on the internet. I would expect everybody here knows how to use it. And there are a great many people who are better teachers for that type of thing than I can possibly be. So if you're interested in just the syntax, that's where you can find it. However, there will be code samples, so some of the syntax will be there. I'm open to questions as we go through this, so please feel free, don't hesitate, we don't have to wait till the end to answer any questions that you have as we kind of come across this, this process and this path of moving from Java to being a Scala developer, and then perhaps going beyond Scala to some other purely functional language like Haskell or one of the many Lisps out there. The first part, when we talk about moving from Java to Scala, the first question we would ask is, why do I want to do this? This is, I've heard things about Scala. Scala is some of the comments that I personally have heard is that Scala is a development language that requires a master's in computer science to understand. Why would I want to go to Scala? It's so new. Scala is, I'm just now starting to hear about it. Are there really any jobs in Scala? So why would I even want to do this? So I kind of based my position on moving languages on a couple of different things. The first is maintaining the currency of our skills. Java's been around forever. It's a very stable environment. There are not too many fundamental shifts in how Java development happens. So maybe with JDK 8, if that gains widespread adoption, we'll have one with the introduction of lambdas. But most likely you're all working in JDK 6 or JDK 7, and you're probably not using a lot of the features that are added in those versions. You're probably using the JDK 5 set or the JDK 4 set, depending on your the legacy, the code base that you're working with. If you're fortunate to be using something truly greenfield, you may be using some of the newer features, but most of us really don't get to do that at work very often. In fact, I know at one of my former employers, they were just now thinking about going to 1.6 because the 1.5 JDK went end of life. And so I'm familiar with that legacy issue. The second part is that exposure to new languages, just like new spoken language, exposure to new language broadens our ability to work in our given language. For those of you who speak a second language, you'll know that the process of learning another language tends to improve the quality of your first language as well as you learn to pay more attention to little details in how you speak your current language. The same is true with software. The same is very true with development languages. The more of them in general that you know and know beyond a passing familiarity, at least know well enough to not mix up the two when you're coding, the better you tend to be in your primary language because you have new ideas and you can kind of take some original paths to accomplish a goal that gives you a little bit more creativity. Insurance against market shifts. If someday Java jobs fall off, which I don't think that's happening, is that happening, Susie?
It is not happening.
It's not happening. But should it happen, having a second job, having a second language or third language or fourth language gives you a little bit of insurance so that you can transition to a new language. What we don't want to be, at least I don't want to be, is the example of a COBOL coder who only knows COBOL, who's been doing COBOL for 20 years, and then all of a sudden, the one company I've worked at has decided that we're going to go away from COBOL to RPG. And now I'm really in trouble. So that is not something that we want to go for. And then there's the fourth reason here, which is truly why I went to Scala, which is I was sick of dealing with Java. I just was tired of it. I've been working with Java since pre 1.0, and I wanted something new. I wanted to get out of, just get out of this. I was worried about what Oracle's going to do with it. I was worried about how the JVM is going to be adopted now that certain features are licensed independently of the main download. Worried about Apache leaving the Java community process, and just kind of worried about that. How is that going to be for long-term viability of the platform? Are we going to start getting nailed down tighter and tighter into Oracle world, which is not the solution to every problem. So those are some of the reasons. So we talked, as I touched a little bit in the summary, is how does investigating this help us learn and how to be better at our day job? Like I said earlier, it forces us to think clearly about what we're trying to accomplish and how we're trying to accomplish it. Because as we get more familiar with our languages, we sort of fall into a pattern for how we're going to code. For loops are coded like this. While loops are coded like this. We don't necessarily think about how the mechanics of what we're doing anymore. And a lot of times we don't even think about the solutions we're implementing because we've done it so many times. I mean, how many people here can pretty much summarize their jobs as sucking data off a web form, sticking it in a database, and redisplaying it later? And I think that's the majority of people here probably fall in that, or feel like they fall in that at least. So you take that, what is a common business platform, a common business problem, and apply it to a new language, and all of a sudden you have to think about how you're doing it, because you've got new libraries. Sucking data out of a form, sticking it into a database in Scala is going to be different than doing it in Spring Web Services. Now, using interoperability in Scala, I could do it with Spring, but it wouldn't be idiomatic, and it certainly we wouldn't really accomplish anything. But if I tried to do it with Lift, which is a popular framework for web development in Scala, that's an entirely different world than trying to do it with Play, which is another popular development framework with Scala. And that's one of the things about Scala that you'll discover as you go into it, is that Scala is really good at, and functional languages in general are very good at developing domain-specific languages. And that means that you can have a Scala application that looks nothing like Scala, and so you have to not only learn the language, you have to go to a new place, you have to learn their domain. You have to learn their domain-specific language for whatever they're accomplishing. And this falls into being able to learn that. The more we learn of these sort of things, the easier it gets. Yes?
Sounds terrible. It sounds like Perl.
Perl is fine.
No,
What are you talking about?
Perl is a beautiful write-only language. But it is not like Perl in the sense that what makes Perl impossible to read is Perl's regular expression syntax, which you can write regular expressions in Perl, and I know from back in the day because I've done this, and go back 2 weeks later and have no clue what you just wrote. And your compiler doesn't know what you just wrote because it's interpreted. Where with Scala being a compiled language, IntelliSense will help me with even my domain-specific language. So those, I don't have to write anything special in IntelliJ, in Vim, anything. I don't have to write anything special to get IntelliSense to work with my domain-specific language. The differences in implementation are significant enough to warrant attention, and paying attention to these differences helps us understand how the Java compiler implements features. And this is specifically focused on things like lambdas in Java 8 are implemented significantly differently, even though they're a core feature to Scala and any functional language. They're implemented extremely, how Java 8 did lambdas and how Scala does lambdas are way different, and what they mean is significantly different. How generics are implemented in Scala is significantly different than how generics are implemented in Java, even though when it compiles down to the bytecode, it's the same stuff. So it becomes a different approach. Now, one of the things I'm not going to cover is, I'm not going to deeply cover generics in Scala, because that is a presentation of its own. And it just breaks us out of the routine. But I think it's healthy to get out of our routine every once in a while and sort of see something new, if for no other reason than boredom kills. Let's see. Oh yeah, going to the more economic perspective to learning a new language. Again, I mentioned being insulated from adverse market shifts. All of a sudden the Java job market falls off in San Diego. Perhaps the Scala job market's picked up. Would we, like to be insulated from that a little bit? I know I would. According to Indeed.com, which is one of the more major recruiting platforms, job posting platforms, Scala job postings have increased 7,000% over the past 2 years. And largely, if anybody's familiar with analytics like I am, what that tells me is they went from nothing to having something. There's still about 4% or 0.04% of the overall economy as a whole. Now, this is not technology jobs. This is jobs posted on Indeed.com as a whole, and where Java is about 4%. So it's about 10% of the Java developer market is now about sitting there about Scala. In contrast, Groovy is Groovy job postings have gone up 11,000%. So if your sole motivation is finding another job that's not Java, and you want something that's really easy to learn, I advise looking at Groovy, because Groovy is really easy to learn. And then again, many people have expressed concern about Oracle's ownership of the Java development language, the Java community process, the JVM, and that moving to another language. Scala actually runs on the CLR as well. Some of the older versions do. They haven't updated it as quickly now that Microsoft has pulled their backing and moved to F#, but it still will run on the CLR. There's still a working group working on making a natively compiled version of Scala, so you can be even independent of the JVM if you want to. Although you lose a lot of features like Java Interop, obviously, when you go that route. But it is possible. You're sick of dealing with Java? Java made a backwards compatibility promise. Scott McNally made this backwards compatibility promise in the late 90s and said Java will always, any version of Java will always support something written in any version of Java, younger than it. So that is why, if you look at the Java guide, and you'll look through something like IOStream, and you'll see about half the methods are deprecated, and they were deprecated in 1.0, that's why they're still there. Scala does not make this promise. Scala is pretty hardcore about, I'll deprecate it in this release and it's gone in the next one. So they really do make, Mark Nodersky and the core team for Scala make a concentrated effort at keeping the language core small and keeping the cruft out, keeping it from becoming this huge monolithic thing. Now, does it have can that cause significant problems going forward for developers? Yes, it is painful. But when you get sick of dealing with all that backwards compatibility bloat and looking at code going, okay, all right, he did enumeration here, but he didn't use type safe enumeration. So now we've got to go class cast it. You don't have to think about that anymore. If it was deprecated, it's gone. The code won't compile, you have to fix it. And then the framework explosion and general ceremony required to do anything in Java does take a lot of the fun out of doing anything day to day. I know I'm speaking to the choir here that most of us don't like really writing deployment descriptors very much, or Spring Bean XML configuration files for people who don't use annotations. So that's kind of the reasons why we want to move. Tools of the trade. All that's really required to do Scala is a Scala compiler from scalalang.org. Scala has a neat feature that's present in a lot of interpreted languages and a lot of functional languages. It's called the REPL, the read eval print loop. In fact, I have a version of it up here. So this allows me, this right here takes away a lot of the need for an actual compiler. I'm running this inside of SPT, which is a Scala build tool. I can, as I'm exploratory coding, working my way through a problem, I can just put it right here, test it out, and see immediately whether it worked or not. None of the code compile, deploy, test, code compile, deploy, test loop is now cut very, very short, because I can work it here inside of the REPL. I can interpret code, very, very complex stuff, run scripts in here. You know, frequently at Core Logic, we automate scripts by writing a Scala script, not a class, and loading it from here to run something that with basically that's just a one-off and throw it away. So we run it inside of the REPL rather than bothering to write an application for it. And you'll find that as you get used to doing this, this cuts down your development time significantly as you're working. So you wind up being able to move a little bit past that, having to live inside of your IDE all the time. Some recommended tools that I use, tools that people who work with, the people that I work with who work with Scala all the time, will recommend as being kind of, they do make your life easier, is that first off, SBT 13, which is the Scala build tool. You can build Scala with Scala C, just like you can compile Java with Java C. You can build Scala with Maven, for those of you who are Maven fans. But SBT is sort of becoming the default mechanism for building Scala. Now, one of the neat things about SBT is if you download SBT without downloading the compiler, SBT will download the compiler for you and set itself up. This is kind of common in a lot of the build tools I've worked with now. Lineage for Clojure does this as well. I think you can do it with Gradle. But you basically, it will install itself. Scala Test is the unit testing framework. And it's a unit testing framework. There's not a whole lot to say about it. It's a very nice unit testing framework, but it is a unit testing framework. And then any IDE or really good editor. And I put this really good editor here because I tend to like to code in Vim. I also use IntelliJ. I don't like Scala IDE, which is Eclipse, but that's because I just don't like Eclipse. So basically any IDE that supports Scala will be fine. Like I said, I use Vim. Vim's nice. One of the things you learn about this is these become significant, and the reason why I included them, they become significant because of Scala's version of not supporting backward compatibility. So Scala 2.10 will support stuff back to 2.9.2, which was the last mainstream version, but stuff from 2.8 that was deprecated is no longer present. So you can't just grab, like you can with Java, you can't just grab a Scala compiler and run it against code that was developed in Scala 2.7 and expect it to work. In fact, you can pretty much expect that it won't work. And the same SBT has a habit of breaking things when they do the later versions, which can be very, very frustrating. Particularly since you tend to have to compile all your libraries in SBT 13 or SBT 12. That can be very, very frustrating. But there are techniques for working around it, but we're not going to go into them because this is a talk on SBT. This is a talk on Scala itself. Was that a question? Did I miss it? The first fundamental fact about any Scala in particular, any functional language, is that the idioms are different. How you do this is different. Every day, it's always different. Scala is a hybrid object-oriented functional language. It's not a pure functional language. So everything you have from object-oriented development, you have in Scala. You have polymorphism, you have inheritance. In fact, you have things in Scala's OO that you don't have in Java. Multiple inheritance is the first, and operator overloading, which from those of us back in the C++ days will remember with trepidation. Having seen operator overloading and multiple inheritance gone very awry. Although Scala takes some novel approaches to limiting the problems that you got in C++ with the diamond problem for multiple inheritance. And it requires a few adjustments to how we approach things. And these adjustments, some of them are minor and some of them are huge. And some of them are huge but look really small. Until you really get into thinking about how you're going to think about solving your day-to-day problems. So I'm going to talk about some of the common different idioms. This is probably the smallest, it looks the smallest, but it is the largest. Final versus val. In Java, to make something unchangeable, to make a const, we declare it final. That doesn't allow anybody to change it. The compiler will complain. But to know that it's constant, I use the common convention is that everything is in all caps. And sometimes it can be declared static. The issue is that we only know that it's final if our IntelliSense tells us, compiler complains, or we go and look back at the code. Go, oh, that's final. Oh, unless you're one of the few shops who's really good about marking everything final, except for the couple things that change. The common idiom in Scala, the preferred idiom in Scala, is to use val. Scala supports two different variable types, vars and vals. A var can change, can be set by the calling code. A val cannot. Principle of immutability, if you read Eric Schmidt's book, Effective Java, he talks a lot about, what was it?
Joshua Block.
Joshua Block, pardon me. Yeah, Josh Block's book. Eric's got the other one. He does effective C++. So, if you look at Josh Block's book, he talked, one of the early things he mentions is prefer immutability. And that is one of the kind of the underlying approaches to, Scala. We prefer using vals everywhere you can. And you find out a lot of times, I don't really need to have things that change when I can use some of the other more advanced functional techniques like mapping and reducing, folding, filtering, things that I might need mutability inherent. And one of the big offenders, iterators, they're inherently mutable, things like that. So this probably requires the biggest immediate shift to go, hey, I'm not supposed to be writing a whole bunch of vars. I want to make these vars. And a good IDE will tell you that this could be a var if you declare it as a val. IntelliJ will tell you, Eclipse will tell you, it'll go, hey, this is a warning, this could be a var. Or it could be a val, you don't need a var here. Collections by default that are imported, they're all the collections that are imported by default are immutable. So they're a create time and then you move through it. And just an example here, if I do var a, this is a mutable variable, well, you'll notice there's some type inference here. That's the other part that's kind of, will throw people for a loop, is that where are my types? Although Scala is a type-safe language, a very strongly typed language. So we have that as being a big change. Another one that kind of helps us out, now I want to see a show of hands. Who here has ever had to catch a null pointer exception? And I see everybody's hand except for Susie and the recruiters. You can still run into this in any way. In any language, you can make it to where you're going to break on a null pointer. But the idiom inside of Scala is if you know this might be nullable, use an option type. They're built in. They're very strong. You've got a couple different ones. You have option, which you'll see examples of some of these in later code samples that I show. You see option, which supports a sum or a none, which seems straightforward. Box type, which is full or empty. Or an either, which is usually got either the correct answer or the exception that was thrown. That type safety, that particular feature is very handy, especially when you mix it with pattern matching. So you can really extract, don't necessarily have to do logic in catch blocks or using exception-based flow control, which is a bad practice in any language, but particularly in Java. When you get to, I'm going to try this, if an exception occurs, I'm going to do this other thing because we know that the data didn't work. Or more often, I'm going to try this, I'm going to catch exception, and then I'm going to abort because I have no idea what happened, and I want somebody to look at it. Where you can kind of work around that with an option type. You can go, hey, if I got a none back, we know something didn't go right. We're not really catching an exception because it isn't an exceptional case, which is the distinction. I still catch exceptions for exceptional cases if I want to, but getting a none back isn't an exceptional case. It just means that we didn't get an answer back. We don't need to check for null because we now have an object for that. We have something for that. And if you use the Guava libraries for Java, the Google Guava libraries, the later versions actually have an option type that they built for Java. But there aren't any native flow control structures, control structures built in to actually work with them. You have the right to work with them, where pattern matching in Scala natively works well with the different option types. This filter and map, filtering mapping, it's called, you'll see it a lot as filter MapReduce. That's kind of the fundamental idiom of functional development. You add that and recursion together, get a language that supports those two concepts, and you probably have a functional language. You only need to add in lambdas and function objects to get pretty much any functional language. Those are the key parts of it. So an example here, how we would say sum all the numbers here from 0 to 10, or 0 to 9, in this case, that are divisible by 2, how would we sum them all up? This is an idiomatic way to do it, with a list. How would I add them all to a list? Well, Scala, I can do it in one line, and you can see a couple things here. One is I passed in a closure, which is an anonymous function. How I would have to, if I wanted to do this in Java, I'd have to build an anonymous inner class, something like you would often see for a comparable, if you wanted to do a different sorting order. And then it would return back. Or if I really wanted to avoid that, and keystrokes were precious, I could just do 0 to 10 by 2. Built-in ranges, mapping to give me stepping through. And this applies to all of the different collection types support these concepts. So you do filter, this, filter, and then I can put map if I want to do something fancy here. And I'll show maybe some code samples a little bit towards the end that are a little bit more detailed than this. Pattern matching looks like a case statement, but it really isn't. In this, you can kind of see here, Java just doesn't have an analog to pattern matching. Java doesn't have an analog to extracting, to basically picking apart objects at compile time and then running them through a pattern matching. The case statement might be the closest, but it really isn't the same. And you see here, each of these is a code block. In this case, this code block only has one line, and I can yield out the result back to whatever's calling it. This, if I wasn't printing the standard out, this actually returns a type of unit, which means it's void. Every block in Scala has a return type, return something. So in this case, this match is a return type of unit because it doesn't actually return anything. But if instead I just said X right here, in this case it's using this option type, which is an integer, so it would be X would be 10. If I just returned X, the value would be 10 here. If in this case this actually returned the string none, the value would be any, because it has to be either an integer or a string type. And the compiler would kick it back and say, hey, this is what you're going to return. You're going to return type of any. If you try to set it to a variable, you'll get compilation. The compiler will complain later on. It'll go, hey, you're not doing something quite right. But for the sake of the example of how to do pattern extraction, this is how you do it. There's not a Java sample because, as I said, there just isn't an analog to this. This is just one of those things you learn about when you're learning with Scala. What are you going to change your case statement to? Because we don't have a case statement in Scala. What are you going to use? This can very easily be used that way, but it is a lot more powerful than your standard case statement. Function objects. I mentioned earlier, we talk about like a comparator, or in Swing, maybe an action for a button, or an event. A lot of times these are just implemented as anonymous inner class, new class, extends, whatever. So you can create that. That's called a function object. It's got its own pattern in the Gang of 4 book, function object. In Scala, you do that a little bit differently. You actually treat the function as a first-class citizen. Function no longer has to be tied to anything, or have its own V table like in C++, where it's actually kind of a second-class citizen. You now have, this function is a full first-class citizen. So declared it, even, signature, takes an int, returns a Boolean. Here's the implementation. And then if I want to use it, filter happens to take in a one-valued function with one input value, and must return a Boolean. So any function can be put in here. I can put one in odd, and I can use the same code. This is what gives functional languages in Scala its expressibility. Because now, and when I'm working with Lith, I may get a form that has 15 of basically the same argument, but I want to delegate it out to different, I want to delegate it out to different implementations to do something different. Now I can just do this. I can create the core function, which is the different, and not repeat any code because I can just pass this function into the function handling my input variables. And you can go, okay, now I pass it off here and just yield the result. The function that does the validation, the section that does the validation, knows absolutely nothing about what goes on in here other than its signature. So this is your standard function pointer type from C, or your first class, your first class function from a functional language, from any functional language. And you can see here this is the return type from that particular function. This is from the console, from the REPL. It just says, election mutable index sequence, integer, and a vector 0, 2, 4, 6, 8, and 10. Pulled out the even function because the range here is this range is inclusive. These are the things that make the language a whole lot different. These are what makes it. They actually kind of make it more fun to work with. I write a lot less code. I write probably 20 times less code and get significantly more accomplished on a single day than I do with Java. And I'm fast in Java. So this is just a great feature. This is what, when I talk with my coworkers, we're all Java people who've converted to Scala. This is the number one thing when I ask people prior to this presentation. I said, what's the thing you like about Scala the best? And they all go, well, I don't have to write nearly as much code to get as much done. It's efficient, it's quick. The downside is it can be really terse. Reading it can be, if you ever go to read like the core library to investigate how something is implemented, reading it can sometimes be a challenge because it does get very, very terse. It's very short, but that gives you a little bit more flexibility and you can be a lot more productive and spend less time doing boilerplate. In fact, there's a lot of boilerplate you just don't have to do, and more time solving the real problem. And that means you can develop, for people who just develop business solutions, you can develop your basic business solution and get it out quickly so you can focus on taking that and doing something novel with it, or maybe moving your business forward. Be less of a cost center and more of a strategic asset to your business than you might otherwise be. Let's see. Did I go past that? Did I skip through the last one?
Smell like the cable cameras.
Yeah. Yeah, because we've got a fold. I think my computer decided to. There we go. So fold is another common idiom in the languages that really doesn't have any Java analog. It's in Scala. What fold does is it basically says, I'm going to collapse a sequence, apply it to a value, and then return a single result. So in this case, summing up the numbers from 1 to 9, this is how I would do it with fold. And basically that's exactly what it says, is fold, if I want to take and make get basically a single number from a list, this is just kind of the idiomatic way to do it. You can fold left, basically means I'm putting this 0 in here, adding in the number here and getting the result, and then the next time around I'll plug in 1 here, adding the number. And then this shows another feature of functional languages, which is called partial application. The plus is actually a function. If you look in there, this is a 2-valued function. And these are placeholder arguments. So when the compiler comes through, it supplements them at runtime. It's called currying or partial application. You hear it both ways. Currying it's not quite the same as currying, but the two are often used in the same context. And this is a feature I'm not talking a lot about. It's very useful, but it kind of takes some special use cases for when you first start working with Scala. partial application can be a very confusing topic, so I kind of avoided talking early on until you get to places where I know I'm going to have one argument that I'm going to pass to every function, and I'm going to call this one function with this one argument that's the same 20 times, but the other 3 are different. That's when you use a curried function. I might curry it down, make it a 3-argument function with that one argument passing as a constant without rewriting the function. That's where you see that, and I usually see that mostly in setup code. Like I'm using code to build the setup configuration for an application, where I might actually run into that use case. I don't run into a lot everywhere else, but there are a lot of uses for it. So I'm just kind of showing it here just as a kind of as an example. The other way you could do it is there's actually a function called sum, which you go here and sum, and it actually becomes that at compile time.
For this specific example, can you use reduce as well?
Mm-hmm. I just picked fold left because it's a little bit straightforward to reduce. You can also a couple other ones. There's aggregate, group by, a bunch of reduce type functions that are part of Scala. They're part of the collections library that will accomplish some of the same things. Well, group by is obviously more useful when you have multi-value collections and you have a key you can group things by. So I could have come up with 2 sums, grouped by the key being is the first number divisible by 2, so I come up with the sum of the even numbers and the sum of the odd numbers. And that would, group by is good for that. Group by combined with aggregate fall into that same pattern. As part of my particular job, I deal with a lot of large flat files of mortgage information. So I get hundreds of millions of rows of mortgage information, but it comes to come to me from servicers in these flat, pipe delimited files. And part of sucking them into a database involves a lot of data cleaning because servicers are lousy at giving you good data. So we've written our own library. We call it Data Badger. We've written our own library for handling flat files. It looks a lot like the Unix command line. We have cut, pipe, and sinks and sources. So basically we can custom build very quickly a Scala application that will parse this file and run it through. We frequently use those SQL-esque functions, group by, aggregate, sort, that are built into the Scala's collection library to give us some of the expressive power and ability to do the manipulations we need to do to make the data, clean the data, make it appropriate for economic forecasting. That's where you see a lot of those. That's really kind of, to me, that's the big use case for having something like sort or group by on the compiler side and not on the RDBMS side. I don't use them in places where I have an RDBMS that can do it for me much more efficiently. But I do, there are quite a few use cases for them when you're starting to deal with number crunching. We use, at CoreLogic, Scala is the analytics development language. So all of the engines that are developed for products that CoreLogic creates are done in Scala. And then we have other languages that maybe are the service platform, maybe are the web platform. In fact, we have 5 or 6 different platforms that we can support, but all of the actual models, the computational engines, are all done in Scala. So they all run on the JVM, they're all written in Scala. And we picked that in part because there's a lot less code to get a working model running, not a lot less formalism. And so you can get some of the expressive artificial intelligence models, the deep leaf neural networks, implemented quickly in here, rather than trying to do it in Java where I just don't have that functional approach. I just can't build the framework in a convenient way in Java to handle that type of numeric processing. Now, we all know it compiles to class files. It runs on the JVM. The bytecode is the same when you get down to it, except for the use of things like invoke dynamic at the bytecode layer. So one of the things I want to talk about too is right now I've talked about all the great things about Scala, some of these great idioms that people use, some of the things that we've run into problems with Scala. First, I've talked about the fact that Scala can look like gobbledygook the first time you look at it if you're not familiar with the domain, because you start getting overloaded operators that look really weird. Lift has an operator that looks like plus, colon, tilde, right arrow. And you look at those and you go, what in the world? And figure out what in the world that operator does. You also have, there's the concept in Scala of an implicit, which basically means that something is in my namespace. I'm not necessarily, and I invoke it from inside of a function, I'm not necessarily going to pass it as an argument to the function, but it's not a global variable. It's an implicit variable. And when you actually look at it compiled, the compiler will actually expand that, plug the implicit into the, as the first argument in your function that you wrote using that implicit. But let me tell you what, that can get very confusing, especially if you get two implicits that clash. It can get very confusing. The Scala compiler is not a good friend at telling you what's wrong in that particular case. Generics are another place where the generic is, it's really easy to write generics in Scala. But when they clash and things don't work, it can get really hard to figure out what's going on. This is the same problem you have with templating in C++. If you're using, say, the STL, and your STL containers clash, you can wind in the same very confusing messages of what in the world is it talking about. It'll take a little while to figure out until you're really familiar with the system. Something you probably haven't run into unless you've worked with Java 1.1 or earlier, Scala can generate class files that are too large for the JVM to load. This is a big problem in 1.1 where the object input stream, which is how JVM loads the class into the class loader, had a hard-coded limit of 64K. It's since been removed, but you can still generate all of these things. This fold left here with this partially applied function that is passed in here implicitly, that becomes an inner class. So you wind up, if you look at actually how classes are compiled, and you actually look at what the output, the .class files, you'll see something like whatever scope this was in, you'll see the scope this was in, a class file for this, an inner class file for this, an inner class file for this, and you can really expand those class files out. I think I can get about 9 levels deep before I start making it where the varying JVMs will crash. If you try to do this on a Linux encrypted file system, give it up, because you will run out of names on a Linux encrypted. You will run out of the file names will actually be too long on the Linux encrypted file systems. That's something we've learned the hard way. It's not core logic trying to run this. It's like, why does you were here and not there? It's supposed to be bytecode. What's going on? And it's just the Linux file system just won't handle it. It's only the crypto file system. ext4, XFS, they all work great. Run into that a few times. Those are probably my biggest, the things that I've noticed in the transition that made going to Scala really actually kind of a challenge. Most of you will not find it all that challenging. The syntax is easy. In fact, it's cut out a lot of cruft. You wind up, you don't necessarily need to write accessors anymore, they're built for you. The actual transition isn't hard. Like any other language, it works best when you have a project you want to do it on. And one thing I have heard from people who work in mixed environments is that places where it's 95% Scala and 5% Java are great. The converse is not true. If you're 95% Java and 5% Scala, that can be very difficult because you just the switching back and forth, the context can be difficult. I haven't had that problem, but I have heard from many people who work in it that is an issue they run into. Switching back and forth is just very difficult. That's what I've got for you. Are there any questions?
Difficult in what way? Like if you wanted to start using Scala for parts of a Java application where you're needing more expressivity, I mean, what kind of problems are you going to run into trying to hard using small bits?
Well, if you're going to interoperate from Java to Scala, it's best to go that direction. Basically, use your Java from inside of your Scala. It's a lot easier. You do have problems in that types are not the same. So string is actually scala.string, not java.lang.string. So you wind up with the name, the names are different, types are different. Now there are built-in implicits into Scala to handle this interoperability for you. Going the other way is not true. So when you go to actually call Scala from inside of Java, then you can wind up with some really weird names because of the name mangling that happens in the Scala compilation process. So you go to import them, it's best to go the other direction. It's best to invoke the Java from the Scala. And the same is true, I think, with pretty much any JVM language that isn't Java. Although Groovy may be a different case. I haven't tried to do it with Groovy, where I tried calling Groovy from inside of Java. I know with Clojure, if I try to call Clojure from inside of Java, you're in for a world of hurt. But just because the way the name mangling happens in the compilation process, it becomes just a real challenge to find the right importing blah 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 $$ function A full $$ B, but the names wind up. It just gets to be really really sophisticated. Anything else? Sure.
I just recently did a Scala project at work, and it's been a while since I had done some Scala, and it was very
Speak
much
up,
the
please.
mind. Sorry, it was very much like I just finished a Scala project at work. It was very much this mind shift, like, okay, it's very easy to write code that looks like Java code in Scala, and I'm a huge fan of functional languages. But I didn't want to write Java code in Scala. I wanted to write Scala code, right? The idiomatic Scala code, functional code. And so it was, for day-to-day things, it was just like, oh, like how could, and so I could have written out very, very quickly, but I think it took twice as long, and then once I got going, it was fine. So, and actually, somebody did the same project that I did, but they did in Java. At the end of the day, my code was about a third of what there was.
Yeah, and we've seen that, and a lot of people have talked to who work with Scala in various professional capacities have seen that, where it is about quite a bit less. I mean, I hear different numbers. One guy, it's 20 times the reduction, order of magnitude, 2 orders of magnitude reduction in code. And then others are like, well, I did about half the code that I did before. But you do, and common things that you would do in Java are really, they are named the same, but very different in Scala. The for loop is a different beast in Scala. It is not the same as a Java for loop. I mean, you can write it the same and you can use it the same, but it isn't the same. It has a greater expanded functionality. You have the ability to do guards. In fact, most of the things where I really only use the for loop, because I use the guard functionality that's part of the for loop in Scala to validate information that I'm going to kick back to a web form. That I'm just going to kick back. And then once I'm done and passes all that for validation, then I just yield it over to the function that was passed in as a functional object and let it do its thing. And that's different. And you can write very imperative Scala. You really can write Java in Scala. But it's not idiomatic Scala. And somebody who looks at it is going to go, oh, a Java developer wrote this. Just like JavaScript, people who are really good at JavaScript will look at JavaScript and go, oh, a Java developer wrote this. It's the same thing. And that's the other part that makes it difficult. It makes the comment hopping back and forth between them difficult. It is actually easier from experience, it's easier to hop from Scala to C++ than it is to hop from Scala to Java, sometimes, depending on what you're doing. It can be a lot easier to just hop back and forth. Because C++ is so different, you don't try to think about how this, you're doing this in IntelliJ, so it must be Java. You don't have that back of your mind kind of already overloaded feeling about what Java, what I'm doing, this is Java, it runs on the JVM, I'm going to code it like I code Java. But once you get into idiomatic Scala, going back to Java can be painful because you want these things, and you get tired of, I don't want to have to write my own accessors, I just want a case class. I want pattern matching, but I don't have it. That's where you get to kind of be, that's where a lot of people who start working with idiomatic Scala start to find the pain in working with Java and don't want to work with Java anymore.
Yeah, I was going to say, so about the second Scala project, and it's frustrating working in Java now. So I think that's one of the outcomes of working in Scala.
Well, and I think that about a lot of languages. I know people who swear by Groovy. I think it's a great language. I don't know if there's anybody here who swears by Groovy. I think it's a great language. They do a lot with Groovy, and they don't want to go back to Java anymore. You do a lot with Clojure, you don't want to go back to Java anymore, because you get to where you just feel like Java is just, and it's like an anchor. It's just keeping me from, I need to run, but I can't because I've got this language that's just holding me down. Not necessarily true for everybody. Some people, we do have people at CoreLogic who refused to make the transition to Scala. Said, I'm not going to do it. I love Java, and I'm not gonna do it. It's fine. You know, there's different tastes for different people. So yeah, it is kind of frustrating to go back to Java and go look at Java and go, oh, all this code to do something so simple.
So, other than developer productivity, is there any significant performance impact between Java and Scala at runtime?
The Scala compiler is a whole lot slower. That's about the only performance difference I've noticed. The Scala compiler itself, it takes longer to compile because it does a lot of these fancy things for you. Runtime, it runs in the JVM. So you're going to have the comparable, if you build something comparable, you'll have close to comparable runtimes. Now you can, just like any other language, you can do something very inefficiently. And it will run very slowly. You might see, if you were to really put it in a profiler and really sit down and look at it, you'll spend slightly more time loading classes in Scala because you just have so many more of them because of the way it has to implement inner classes. But when you get to real runtime, we don't notice any, when we process huge data sets, we do not notice any significant difference.
So I was going to say, in terms of performance, it really depends on what your paradigm is. If you take a look at parallelism and what it takes to get that performance in Java in terms of the, say, coding synchronized blocks and you're handling all the threading, or using some paradigm or idiomatic ways of doing it in Scala, that can make a big difference in terms of overall performance.
Yeah, one of the things I'm not showing here, that's one of the big things about Scala, because it's another one of those, oh gosh, this would be another class all by itself, another doc all by itself, is the actor system that's built into Java. The multi-threaded systems that are built into Scala. The multi-threaded systems that are built in, like the parallel collections that are part of Scala, that are built in. That's a topic all by itself. And I use the ACA actor system that's now part of Scala 210 to handle my heavily multi-threaded loads. Actor-based programming is different than like thread-based programming. It's a different paradigm. You're not, with threads, it's expensive to spawn up a thread. You don't want to spawn up many of them. You want to know how to pool them. Where actors, you kind of make the smallest possible actor that completes a unit of work and then throw it away. It's done, throw it away. It's done, throw it away. Build another one.
So there is actually some comparisons between Java and Scala out there, and I think one of the more important one, which actually compares apples to apples, is in the Play framework, because it exists both in the Java version and in the Scala version. And it turns out that the Scala version is something like 10% faster in many cases.
Yeah, I have not read that study, but I can believe it. And I think that largely becomes through just a reduction in code. You're just not building as much. So when you have fewer lines of code to go through, you can see a reduction. A lot of times I don't see it because I'm frequently working on things that are going to run for 10 hours anyways, and if it's going to run for 10 hours, what's 2 minutes? I don't really care. What I care is the fact that I've only got 10 hours. Can I process all the data I've got in 10 hours? Which becomes it's a different question. It's a different way of measuring performance. So I'm doing economic models, econometric models, stuff where I'm just taking huge amounts of data and all I want to get out of at the end is an equation. So that's what I want. Yes.
I'm going to ask this because I did a bit of Ruby. One of the things I really like about Ruby is there's a lot of ways to jump into the REPL in a particular context. Can you do that in Scala? So like, I want to be looking at something that I want to do in a controller, for instance, and I want that context so I can play around in there.
It depends. If you're using, it depends on the framework. Because really what you're talking about is not so much a feature of Ruby. It's a feature of.
Oh yeah,
it's a
absolutely
feature of Rails. Or what are you using Sinatra or?
Take your pick. It's actually not. You're right. It's a gem that you put in.
Yeah, it's a gem that you put in place that takes you there. With Play, you would get the same type of behavior. You'll be able to steady a step into your controller. Play is probably going to be the closest analog to most of the Ruby web development frameworks. Mm-hmm. Lift, you don't get that because Lift is entirely different. And it's a purely functional way of approaching web development. So I don't necessarily have controllers in the same way that you would. It's a view first development, so you have snippets. You can configure the REPL to do that.
Okay.
It's just a matter of wanting to configure the REPL to do it and how much effort you want to put into it. SBT does it for me.
Okay.
For a lot of, like if I do lift in SBT, it will configure it that way for me. I just have to tell it this is what I want in that context.
Okay.
But it like Ruby, it's a gem or it's a plugin that you're going to put into SBT to give you that functionality. But it is possible, like so many other things. I mean, REPL-based languages, and you can have. I've seen REPLs for Scala that are very, very fancy.
Okay.
Where the one I showed earlier is just basic. You know, I just threw SBT on today. Here's what the REPL looks like.
So Scala has one thing going for it that Ruby doesn't. And I know you don't like it, but in the Eclipse you can actually get something called a worksheet.
You can do that in IntelliJ.
All right.
So same concept.
Point taken.
Yeah, same
But
concept.
so essentially you wouldn't be doing that, you'd be loading up your file and working inside of it, and at the end of it you would have, whenever you made a change, you would see that change take over your whole file.
You basically would set, in Eclipse, you'd set up a worksheet that has all the imports you need, and you just fire it off and just it evaluates it right there for you.
Yeah.
If you're doing Vim and doing continuous compile in SBT, you won't necessarily have that. You'll spawn another SBT into the console. But it's just a different way of approaching development. So, yes?
Just a few questions about kind of runtime semantics. Stack traces, do they get you to the lines of code, or do they get you to the, are they more kind of correlated to the byte code that gets generated from your source code?
Depends on how you compile it. Usually, I mean, because I can tell Java not to turn that stuff off, not to turn all that stuff off. If I don't compile in debug mode, you're not getting in Java.
Right.
Yes, you get all that same. It's the same stuff. They will be more verbose necessarily, because if you're doing something that's down in an anonymous block, it's in a block somewhere in there, like in that plus per se. Say somehow I managed to get an A out of 0 to 9, the range 0 to 9. Won't happen, but in this case, I plug it in here and got a class cast exception. The stack trace would be different. It'd be longer because of the nature of the anonymous part of that. But it's still there. You will still get to the same code. You can still control click in Eclipse or in IntelliJ, or you just go to the line in Vim, and you will see the line of code that gives you the problem.
So like debugging and heap analyzers.
Step through it, all that stuff. Most of all that stuff works off bytecode anyways. So.
Yeah, we're used to correlating that back to Java code.
Yeah, it will correlate it back for you. So you can use like your kid works fine.
Okay.
With it. JMap works fine with it. The standard heap utilities that come with the JVM work with it. It's just you get a longer stack trace.
What about code swapping at runtime? Like how is you working with an IDE on a running system where you're not swapping classes?
JRebel works great.
With Scala, okay, great. Thanks.
One of the few things that I encourage people to buy is JRebel really does work great, particularly when you're dealing with web stuff that sometimes won't, but regular hot swap won't do for you. But yeah, those work, pretty much the same. When you get down to the runtime semantics, it's really just bytecode running in the JVM. The difference is you now have Scala lang.jar plus whatever feature in your class path.
Have you had to instrument and monitor any of the code that you put out?
I do. I primarily use your kit for profiling, but I do have instrumenting and monitoring. Frequently implement instrument monitor. I actually use CA Wiley with this too for runtime monitoring. Wiley gets a little bit confused with the inner classes, and when you're used to using a tool like Wiley, and you look at the stack traces inside there, and the transactions can get a little bit confused. But I have used CA Wiley with it in production for real-time performance monitoring.
Do you know of anybody that's used New Relic?
No, off the top of my head. If somebody wants to give me a license, I'd be happy to use it. I'll try it out for you. Which is sort of the Scala thing, is just that willingness to explore. You have to do a lot of it. I read a lot of this. You have to read a lot of the Scala source code as you're getting into the language. I don't know how many people actually have really looked into the Java source code for the Java standard library and figure out how things are being done. In Scala, we do a lot of times you do that to understand what in the world this means. What does percent mean in this context? Anything else? Yeah.
I like programming in Python because of its brevity. assuming I get over the learning curve of functional programming in syntax, would you say that Scala is very readable the way Pythonistas say something is Pythonic?
Depends on how you do it. If you build your own, if you overload a lot of operators in a nonsensical fashion, then no, it's not going to be as readable as Python. Python has some limitations there that this doesn't. You do a lot of multiple inheritance, it can be a real trick to read. But if you use those features with restraint and where they're appropriate, yeah, it's just as readable as Python. I use Python for my operating system scripting. I don't write stuff in Bash anymore.
Would you say Java is not readable then?
No. Idiomatic Java can be very readable, it's just very verbose. It's the difference between reading the abstract and reading the whole paper.
Well, isn't it the point then?
Yeah. Well, it depends on what you want, right? If you need that formula that's on page 53 of the paper, you want to read the whole paper. You don't want the abstract. But as far as brevity, actually, yes, the abstract paper is perhaps not the best analogy. Maybe a better analogy would be the difference between reading modern English and Old English. A lot more verbose, a lot more formality, formalist language, versus a lot briefer, more terse language. So, I mean, I don't tend to choose languages based on the brevity of the code that I can put out. It's nice that it's brief, but I like Lisp, and Lisp uses a whole lot of parentheses. So, it's not usually something that to me is not a high, part of the significant criteria for why I'm doing something.
What kinds of problems does Scala not solve very well versus Java?
If you were just basically sucking something out of a web form and going to put it back in, the tools that are there for Java, not that you can't do it with Scala, because play is very fast. You can put something out basically and play very fast. But if you're trying to do this in a JEE environment, you have to do it on an app server such as WebSphere. Probably wouldn't bother with Scala. So you just wind up with the cruft from JEE that you are going to have to work around to make Scala work. It's kind of outweighs the benefits you get from Scala. I mean, I don't want to spend 90 hours fighting with figuring out how to get EJBs inside of EJBs mixed and compiling with Scala, with JMS. And that's, at that point, if you're going to do something like that, yeah, forget about it. We use it for integration problems. I've used it for a lot of integration problems. I use this versus, say, Java. JMS is fine, but if you have to start calling container managed beans or old style J2EE or JCA components, stick with Java. Your life is probably going to be a lot easier. I just couldn't imagine calling JCA for inside of Scala. It'd be great. It's not something I would want to do.
So when you say you use Scala for integration problems, can you expand on that?
Probably, I use Apache MQ. I use Camel as a message queuing platform to move back and forth between like .NET. So I can use AMQP to pass stuff back and forth between .NET on different platforms, rather than doing web services, which we could do web services just fine. But a lot of times I like the reliable delivery that you get out of a real message queuing platform. That's our primary integration besides file-based, where I get big old honking data file. Process. Did you have a question?
Yeah, I was wondering about the parentheses on function calls, since they're optional in Scala. What's the idiom for whether to put them in or not?
Usually the idiom I see is to omit them in every case possible if there is no argument. If there's an argument and it's the last thing on the line, you can omit them. If it's in the middle, you can't, period. You just can't. You won't let you. You have to have them. That is a feature that is actually can be turned on and turned off. That's a feature that's actually turned on by importing a particular compiler setting. The way the Scala compiler works, for people who aren't really familiar with it, is there's a base core language, and then advanced features are enabled by importing things from the Scala.compiler features class. So you pick out the class you want to get that feature that you may not have. So say Groovy has an expando meta class for which is basically a map-backed class. So you can call a function, you can call a class, and if that property isn't there, it'll look in a map to see if there's a value for it and return it. Scala has the same concept, but it's not turned on by default. You have to import dynamic maps from the compiler feature set. The other one that's similar in the same vein would be point free. So not using the point to invoke methods, which is, you see, that's used in Scala test, uses that extensively.
It's used right there.
Yeah. We got .2.9, that's part of the point free. Actually, in that case, 2 is actually this is actually a static function. Well, actually, it's a static function on the range class. But yeah, it's point free there. That's in a couple places. So generally the idiom is people, from what I see, and when I look at the Scala code base, they pretty much use parentheses everywhere, except for if it's an empty, if it's actually an empty parameter list, argument list, or there's only one argument and it's on the end of the line. It's just omitting them sometimes does make it very hard to read, because you don't know whether is that a function, is that a parameter.
So you're saying they mostly do use them, or they mostly don't?
Mostly do use them. Mostly do use them. I omit them every time. If there are no arguments to them, and I'm going to chain it, I omit them. If there's arguments, you have to have them. If it's on the end of the line, I omit them. The compiler, the IntelliJ will complain. It will say you're invoking a Java method, but omitting the parentheses. It will actually complain if it's not a native Scala method, but it'll compile. It'll work.
Features that don't have a strong analogy in Java, like pattern matching and operator overloading and implicits, you find yourself using those a lot?
Pattern matching I use all the time. Pattern matching is a fundamental.
And what for?
Just about everything. There's a concept called the case class, which is basically a class that carries, if I don't want to implement equals hashcode toString, I can implement case class, which will build them for me. It has some downsides, which I can't extend the case class. It's final. But if you make a case class, then it can natively take place in pattern matching. And so this right here is pattern extraction. So X is a pattern here from this sum, and I'm extracting that variable out and using it here. So anything, could be here, basically a variable declaration. The case class can natively participate in this, where a standard class can't. You have to do some work to pull out and extract it. This is a very common idiom. This is you see all the time. Most of those features, folding and all those features that don't have it, operator overloading is different than these features that don't necessarily have an analog. Operator overloading was explicitly excluded from Java. Operator overloading existed in C++, and when they built Java, they made a language decision and said, operator overloading has caused no end of problems in C++ for business developers. We are going to make a business-friendly development language. We are going to exclude multiple inheritance and operator overloading. And they kind of did. Well, they definitely excluded operator overloading. They excluded multiple implementation inheritance, where you have interface inheritance through interfaces. Scala adds both of those back. I get multiple implementation inheritance and operator overloading back. Operator overloading is most used in domain-specific languages. That's where it makes sense. Most things, the operators I've got are fine. And if you abuse it, you can really make it where it's impossible to read your code. Impossible to debug, because you've got so many operators that mean so many different things, it can just be very difficult. So, multiple inheritance, you use it with the trait system, which is mix-in, similar to what Ruby has. That's your implementation inheritance, and that's used all the time. In fact, one of the most common ones is you put your logger in a trait, you mix that in everywhere, and then you have logging. You have a logger available without declaring it explicitly in your class. That's like probably the #1 basic case of multiple inheritance. So it makes sense. Anything else? Questions, comments, rude remarks?
That's it.
That's it. Thank you all.